All right, so this video is just going to be about kind of like reviewing through some of the stuff that we've already done. But I just wanted to point out that if you have homework questions for me today, you can do that through email, right? Remind works really good, and also Canvas messages is pretty cool. And I can send you videos of work. I can send you screenshots of work. I can send you all kinds of things. So if you have any questions about anything or need hints or help, please let me know today. All right. So we're going to just kind of like mess around today. And a lot of these, I would recommend just like hitting pause on the lesson and then trying them on your own. And then after that, you can watch me do them, and that seems to be like a way in which you could try to like do something on your own. And if you get stuck, then I can help here. But um, you really should know how to do a lot of stuff. The one thing I'm going to give as a hint for all of this today is we're going to use formulas. So if you think back to things that we did in the past, you may encounter like a sine addition formula, a plus b. Like you might need to go back and review those, hit pause on this video, and then just review all these. So we had sine, cosine, and tangent on the subtraction and addition formulas, right? We had all these kind of things. We also had double angle formulas. So we had like sine of 2a, right, would be 2 sine of a cosine of a. So I'm just going to say on all these, and we had a bunch more formulas, so you might want to find those. But I would say that today we're going to incorporate into some of the inverses and equations that we've done, the problems that we've done. We're just going to incorporate formulas to kind of mess around and bring back the old unit a little bit. I know that some of you are probably sighing and saying that that sucks, but that's just kind of like the way that we're going to wrap up this unit. So we're going to kind of tie it all together with some of those formulas and identities. All right, so find all solutions for the equation tangent of 2x minus 2 cosine of x equals 0. So like I said, if you want to try to figure out some formulas and different things that you could do, you can hit pause and try and solve that. But we're going to find all solutions. So if you want to keep watching, you can. But here we go. So the one thing that does concern me about this problem is the following. I'll highlight it. Is this right here, 2x and x. So, the tangent and the cosine don't bother me too much because tangent is made up of cosine if we really think about it. But what does bother me is the fact that it's a 2x and an x. So they don't really talk to each other. So what you're going to have to do is the reason formulas are going to come into play is because the formulas are going to be a way in which we can go away from the 2x and just have x throughout the whole problem. So you could use a tangent double angle formula. So tangent double angle formula looks like this: 2 tangent of x over 1 minus tangent squared, if you remember. That is the formula. But still, that's of little help to you because what happens after you put that in? Now you have a bunch of tangents and cosines and all that kind of stuff. So there is this identity that says the tangent of x is equivalent to sine over cosine. And I kind of like that one. So I would say tangent of 2x is sine of 2x over cosine of 2x minus 2 cosine of x equals 0. And now from there, I have some double angle formulas, right? We have a sine double angle formula. We also have cosine double angle formula. Now remember, there's 3 cosine double angle formulas. And so sine double angle formula, there's only one. So 2 sine of x cosine of x all over something minus 2 cosine of x equals 0. Now we get to pick. I'm going to tell you that I'm going to use 1 minus 2 sine squared. The only reason I like that is I think about what I'm going to do next. And so in solving equations, we would usually say in a math class that factoring always makes life easier, right? So it's already set equal to 0. And if you notice, I've got a 2 on the numerator and a cosine on the numerator. And if you think of this as a fraction, you already have a 2 and a cosine on the numerator. So you actually have the greatest common factor of 2 cosine of x. And then that would leave you with sine of x over 1 minus 2 sine squared of x. And then minus 1. Like all you would be left with is 1 over 1, which is 1. And that equals 0. So if you kind of think about, well, okay, why did you choose 1 minus 2 sine squared for cosine of 2x? Well, the reason I did is because once I took out the cosine and the 2, all I would have left inside this parentheses, all I have left is just a sign or just signs left in the problem. And that is helpful because if you're going to try to solve it, then those actually talk to each other. So notice what's happened. We've gone from a 2x on the inside. Now throughout the whole problem here, when you're looking at that blue line, all the variables are just x. So that's really helpful in trying to solve. So now how do you solve by factoring, right? We factor out the GCF, so I can take the GCF here and go 2 cosine of x equals 0. And then I can do sine of x over 1 minus 2 sine squared of x minus 1 equals 0. And then I can solve each one separately. And so as we're solving, this one is the cosine of x equals 0. That would be at, pi over 2 and 3 pi over 2, but it says all solutions. So if you're picking pi over 2 and 3 pi over 2, they're pi apart. So I'll just say plus pi n. Okay. Now the next one, got a fraction. You could just clear the fractions, right? How do we do that? We just multiply by the common denominator, which would be 1 minus 2 sine squared of x over 1. So I'm going to distribute it to all three things. So that'd be sine of x. And then negative 1 times 1 would be negative 1. Negative 1 times negative 2 would be plus 2 sine squared. And then times 0 would still be 0. Oh, look at us, guys. Look at us. We can factor, I hope. 2 sine squared of x plus sine of x minus 1 equals 0. Oh, let's do this. This is 2 sine of x. This is sine of x equals 0. I'm going to put a plus 1 here and a minus 1 here. Time to solve. This would equal sine of x equals 1/2, and this would be sine of x needs to equal negative 1. So this would be x equals 3 pi over 2 plus 2 pi n to get coterminal angles. This one's going to have two answers, pi over 6 plus 2 pi n, and x equals 5 pi over 6 plus 2 pi n. And so let's take a look at what we've got. We've done a lot of math here, and we've used a lot of formulas. So let's see if I can kind of grab that, make it smaller a little bit, get it out of the way of the other stuff. All right, so we have those things. When we're looking at our answers, though, there is some overlap. So you could just kind of like take a look. This one that I've just highlighted, if you start to really think about it, it incorporates all the answers that this one would give me. So it's just kind of redundant. So I don't know if I really need this one, if that makes sense. I don't really need 3 pi over 2. However, if you left it, I guess I wouldn't be too mad about it. It's just more that it's redundant. So I mean, maybe you really only need this one, and you pick this one. You couldn't get rid of the 3 pi. You couldn't get rid of pi over 2 plus pi halves in because you need this, because this has more. This one has more answers than this one, right? So this one just goes to 3 pi over 2, that negative 1 every time. This one actually goes to 1 and negative 1, right? That's where like cosine 0. So this one includes this guy. So, but if you left it, I wouldn't be too mad about it. But if it was like multiple choice test, you wouldn't see the fourth thing there. You probably would just see the 3. All right. So it's kind of wild, but if I'm giving you like some tips of what to look for, you're looking to reconcile, if we're back to the beginning, you're looking to reconcile these two things. You can't really make them talk to each other until you have all x's, right? Or somehow you were able to get this to be 2x if that was possible. But you're trying to kind of use some formulas to get you to a place where now all the trig functions and all the variables can talk to each other. And you can use identities, you can use different solving techniques like factoring and all that type of stuff to help you out. So that's kind of the name of the game with these today. That's the fun side of it, is using our idea of formulas. So I've got two here, right, that you could do. If you want to hit pause and try them on your own, I would totally recommend that. Notice we're solving just for the interval of 0 to 2 pi. So I would just maybe recap some of the formulas you've got, think of some ways that you can do it, and then once you've tried it on your own, you can come back to the video and watch me do it as well. But I'm going to get started. They're not too bad, but there are a couple different ways that you can go about doing it. So we'll see. All right. So hit pause or just keep watching. So cosine of 2x can be three different things. I'm going to pick 2 cosine squared of x minus 1. And the reason I'm going to pick 2 cosine squared of x minus 1 is because that way then, right, I have all cosines in the problem and they all have just the variable x with them. That way they can all talk to each other. I could do things like factoring, and I can solve for x pretty easily. So 2 cosine squared of x plus 3 cosine of x minus 2 equals 0. So we have 2 cosine of x, and then cosine of x. Plus 2 here, minus 1 here. That equals 0. That looks good. So then this would be cosine of x equals 1/2. This is going to be cosine of x equals -2. So cosine of x can't equal -2. That won't produce any answers. But cosine of x can be 1/2, and that would be at pi thirds and 5 pi thirds. Okay. Hopefully that works for you and you got the same thing as me. I'm sure there's some other ways of going about it. I could see a few, but I thought that one worked well. All right, second one, if you want to, once again, you're like, okay, I'm feeling more confident. Let me do this without any help. Perfect. Hit pause. Okay. Now, if you're actually watching this, some people will remember that when we used to go to school and see each other face to face, you would remember that I said that if you substitute in a formula for cosine of 2x and you substitute in a formula for the sine of 2x, if you substitute things in and then you're going to have to distribute and do work, like you're going to make the problem messier. So it's always easier if you could think of a way to simplify without making the problem messier. So substitution at times can always make the problem messier. But what if I could simplify, and I'll give another word for it, what if I could condense? We used to play this game when we used to hang out in class. We used to play this game. It was called Name That Formula. You remember that? Name that formula. And we said that the name of the formula is what you do. So if you look at this and it's all coming back to you now, it's all coming back to you. This right here is a formula. The question is which formula is it, right? And it is a cosine subtraction formula. So the name is what you do, right? So we're going to subtract 2x minus x. So it's cosine of 2x minus x. That's the formula. So instead of plugging in double angle formulas, which are some things that people will do, what that does is make the problem worse. I've got cosine of 2x minus x equals 1, which this is just the cosine of x equals 1, and the cosine is 1 at x equals 0 radians. And then we're done. So it's like, if you get real strategic about it and you can see that something is a formula, then all of a sudden, if it condenses down to one thing, that is much nicer. So those are a couple different ways in which you can look at some of these problems and recognize the formulas and how to use them. But I just wanted to add that one more element to our solving equations. So if we're kind of reviewing equations before we move on, right? With equations, we've just done simple equations. It's been really good. Simple equations where we've solved for angles. We've used identities in our equations, so substituting in identities. We've done that. We've used inverse functions, right? And we've had to utilize inverse functions to solve equations. Definitely a good thing. And then last now is, I guess not last, but we did where there was kind of like a period change where you had to find more, like period changes in those equations. And then the last would be formulas. So we saw we're now utilizing some formulas. So I would say all 5 of these you should know for your test come next week. But there you have it. So solving equations, those would be kind of the key components, along with the 2 types of instructions, right? So you have find all solutions or solve for the interval of 0 to 2 pi, all right? But that's kind of your review for equations. Hopefully that all looks good to you. If you have any questions, send them my way today. All right, so with inverses, the hope is that you could explain to me how to do each one of these problems. So if you want to kind of pause and look at each one, there they are. If you want to hit pause and try to explain each one, that would be really good. But if you don't want to hit pause and just want to hear me talk about them, then that's fine also. And then you know what you need to study for the test. So there were 6 trig inverse functions. If you go back to the notes or watch the video again, the domain and range for each one is given. And you should know a little bit about it. Remember the ranges are the things that you really should memorize, and those are either going to be from negative pi over 2, essentially. Sometimes they don't have brackets, to pi over 2, or the other one is 0 to pi, and sometimes they don't have brackets, right? So like those are the 2 ranges that you're dealing with. Inverse sine, inverse sine is this one, right? Is negative pi over 2 to pi over 2. So where would inverse sine be 1/2? That would be a pi over 6. So we're just going to say negative pi over 6. Simple as that. Okay. For this one, we don't know the ratio 3/7, so that presents a little bit of a challenge. What we said is that since this produces an angle, right, the arc cosine of 3/7 produces an angle, we said that you want to draw a triangle in the correct quadrant. So inverse cosine is from 0 to pi. And so this would be quadrant 1, 3/7. So here's my picture. So draw a triangle, 3/7 is the adjacent over the hypotenuse. So here's theta, 3/7. And you're going to need to find this in order to do the cotangent. So that would be 49 equals, we'll call it, let's call it y since it's going up and down, y squared plus 9. So then it'd be 40 equals y squared, square root 2 square root of 10 is the y. So now if we're doing cotangent, that's adjacent over opposite. So we would say this whole thing equals 3/2 rad 10. Oh, the world will explode if I leave the square root on the bottom. So let's go 3 rad 10/20. Hopefully that sounds good. Okay, 3 rad 10/20. All right. So drawing a triangle. There you go. Now, this would be the one that maybe looks weird, but if you watch the video that I did on inverse functions back on, let's see, what is it, right here, April 3rd, or maybe it was April 1st, one of these 2, I don't know, maybe it was April 1st. I think it's probably April 1st. I don't know, April Fools, who knows? But I kind of referenced a problem like this, but now we're actually going to do it. So if you want to try it on your own or explain it on your own, you can. But in this case, we're going to use a formula. So if you think about it, this produces an angle theta, okay? So really, if you start to think about, this is saying sine of 2 theta. Well, what is the sine of 2 theta? Well, we just used that formula. The sine of 2 theta is 2 sine of theta cosine of theta. So what you're going to do in a problem like this is you're still going to draw a triangle, right? But then after you draw the triangle, you're going to have to come over here and you're going to have to use the formula. And in that way, you'll be able to do the sine of 2 theta, right? Because this is the theta that we're talking about. So quadrant 1, just like the last one, the adjacent is 3, the hypotenuse is 5. That means the opposite is 4. And so now there's your picture that you can use to reference as you fill in the formula. So 2, the sine of theta would be 4 over 5, and the cosine of theta would be 3 over 5. And so that would be 12 over 25. So that's 24 over 25. Okay. And that's that. Looks kind of weird, but it really isn't too bad. So like I can make up another one. You would have like, let's see, looking at a tangent double angle. So tangent or maybe tangent addition. Ooh, tangent addition, watch me work. Here we go. What? Tangent, inverse tangent of like, I don't know, 4/3 plus like inverse tangent 5/12. Yeah, that works. And in that way, this is actually an angle that's different than this one, but basically it's the sum of 2 angles. So right, it's essentially the tangent of x plus y, which is a formula tangent of x plus the tangent of y all over 1 minus tangent of x, tangent of y. And this one actually doesn't require you to draw any triangles because you already know what the tangent of x is. The tangent of x, if you call this, right, say this thing, whole thing equals x and this whole thing equals y. The tangent of x is 4/3 and the tangent of y is 5 over 12 by nature of the inverses. And then you can plug them into the formula. So they look weird, but they are a way in which you can kind of reference the formulas, okay? So recapping the review, you should feel good about inverse functions, right? All 6 of them, right? And doing weird things like this. Maybe it's just straight evaluating, right? One answer only, please. Maybe it's using them in equations, or maybe it's doing weird problems like these ones. But that would be kind of the scope of it. So as you can see, those are kind of the critical things that you should be able to do for the test. But also, as you can see, we were just messing around with formulas today. All right. So if you need any help, let me know. And I wish you all the very best. Okay.